Let's talk about the Gauss Theorem of Divergence. The Gauss Theorem of Divergence says, by the help of Gauss Theorem, we can simply evaluate the surface integration into volume integration, that is divergent into f into dv v cap. This is the overall definition of the Gauss theorem. The surface integral means we multiply the surface, that is the it is a surface, and volume means we multiply we integrate the volume, and linearly means linearly integrate, but surface means we increase this is the surface, so we surface integral simply integrate by length by height. So, or for volume, in the volume of pen we can integrate the by volume integral. This is the overall meaning of Gauss theorem. So it says this, for example, let's see some we have a matchbox. You see a matchbox. So when we see a matchbox, it was a cubic form, okay, but by the for example, this is the matchbox area, this is the matchbox surface, but this is the overall cube form, this is the volume. But when we look out from the surface, the above from the surface, it sees like a surface integral. So Gauss theorem says that we can convert the surface integral into it's a volume integral. So proof is very simple. For example, this is our x, y and z axis, x, y and z axis. For example, we take a small cube. This is our cube, okay, this is our cube. For example, this is the A, and this is our A surface, okay. So like the pen is like a flux which are passing through the surface A, that is the left hand side. So this is the flux, they say fx as point P1, okay, and the length is dx, and this length is dy, and this length is dz, okay. So the simply for solving the Gauss theorem, so flux through left space, which become minus because it is outside from the surface, become minus of fx, we get integrate, this is dy and dz, okay. This is the surface, okay. Now the face of the left hand side, okay. And now since we know that this is the infinitesimally small cube, so the integration is the same, the linear integration of dx is the same as the its area, that is dy and dz. So it become fx at point P1. So the flux is become at fx at point P1 is fx at point P1 dy into dz, okay. And same as for right hand side, it become fx at right hand point dy and dy into dz. So the value of fx at point 2, it is this is the right hand part, this part, okay. Say this is B, and the part is this fluxes are passing from point A, so the point fx is point A, plus since we know that this is the direction when we differentiate the direction, so it will become del x partial differentiated fx dx means its length, the dx length, and the overall area, which is dy and dz, okay. So the total flux become fx p1 dy dz plus del dx fx dx dy dz plus fx p1 dx dy dz and else. So this get cancel out, and overall we get dl upon dx at fx dx and dy and dz. This is the total flux at x axis, and the fx is the x component of this flux. And same for y axis is become d upon dy fy dx dy and dz, and same for z axis, it become d upon dz f z dx dy dz. So the total flux at the surface integral, because we since we totally calculate the surface from this side x-axis, from y-axis, from z-axis. Now the total surface, since this is the surface, is the face side of integral, so it become f into ds, because it is the same, and the total, when the sum up of all, it become the surface integral. So that's why we integrate it. So it is become d upon dx at fx dx dy dz, and same for d upon dy, this is fy dx dy dz, same d upon dz fz dx dy dz, common all this become dx dy dz, and overall we get d upon dx into fx plus d upon dy into fy plus of d upon dz into fz. So this is the overall dv, and this become the del. This is divergence. In the previous class we talked about the divergence. So the overall meaning is the surface integration of f into ds become divergent into divergent f, because fx dot f, and it become dv, and the total, the summing up the all the element, since we for one and add of all, we get f dot ds volume integral divergent f dv we get. This is the overall meaning of the Gauss theorem. Again, means first we prove the flux from the left face, the x component, and then through the right, and then through the overall all sided, and the overall summing up become the surface integral, and when we again calculate, it become the divergent f, and so overall it become Gauss theorem proof. In next video we talk about the Green theorem and some interesting fact about it. I hope you understand.